a lot of the time when we're finding probabilities, we might have some information about what has happened. And so if we know that a certain event has happened, we might be given that information. We know that it's already happened. That's some extra information. And we might want the probability that something else happens. So the probability of an event A, given that event B has occurred, is called the conditional probability of A given B. And we denote this by probability of A and then with a bar and a B after it. So that means that we know that B has happened. And we want the probability, given that information, that A will occur. So let's look at an example of where this might be helpful. We're going to open the file mortgage default data in Excel. And this is from a bank that's interested in the mortgage default risk for its mortgage customers. Some customers have defaulted on the mortgage, and some others have continued to make on-time payments and have not defaulted. And we also have information about the age of the customer at the time they took out the mortgage, their marital status, annual income, mortgage amount, number of payments made by the customer per year, the total amount paid by the customer over the life of the mortgage, and whether or not they defaulted. So let's look at marital status and whether or not they defaulted, and let's do that by making a pivot table for those two things. So here's our data. We want to make a pivot table for marital status and whether or not they have defaulted. So over on the right, there's a default on mortgage. And so what I'm going to do is I'm going to highlight this whole table. I'm going to go ahead and make it a table in Excel. So I'm going to hit Command T just to make it a table. We don't have to do that. And then let's go and insert a pivot table. And let's put this in a new worksheet. Okay. So let's make a pivot table with marital status and whether or not they defaulted. I'm going to take marital status and drag it to rows, and then default to columns. And then I need to add up how many people are in each of these categories. So I could use any of these. I'm going to use customer number, drag that to values, and I don't want the sum. I just want to count the people in each of these categories. Okay, so here we have a pivot table showing the number of customers who were married, did not default, who were married and did default, and same for single. And so let's say that I wanted to calculate some different probabilities. Maybe I wanted to calculate the probability a customer is single and defaults. If I wanted to do that, I'd say, well, I'd look at the number that were single and defaulted, which is 41, and I'd divide by the total, which is 300. And so this would end up being about 14%. And let's say I wanted to find a few more probabilities using this table. So let's say we wanted the probability that someone is married and does not default. Let's see, I'd look at the number who are married and do not default, which is 64. And I would divide that by my total of 300. Great. If I wanted the probability someone who is married will default, this is one of those conditional probabilities. So here, I'm given this extra information that they're married. That tells me instead of looking at the overall total of 300, I know that my customer is one of these married ones. And given that they're married, I want the probability that they will default. So here, I would say, okay, of the total 143 married people, 79 of them defaulted. So this would be 79 over 143. That would give me the probability that they will default given that they're married. If I wanted the probability that a customer who is single the probability that a customer is single if we know they do not default. So here what we're given is that they do not default. So that means that we're in this category where they do not default. And in that category of 180 people, we want the probability that they're single. So this would be 116 over 180. So that would be about 64%. And I might want to also, if I'm looking at my pivot table, I might want to see my overall probabilities as part of the table. So if I go up to Pivot Table Analyze, and then over here, I can click on Field List to make things show up again. And then if I go over to the right, instead of, right now I'm looking at count of customer number, which is what I want, but I might want to show these as a percentage. So I'm going to look at percentage of grand total. That will give me in each of these categories the overall probability that I choose something in each of these categories. So the probability that a customer is single and defaults, we said, the probability that a customer is single and yes does default, we said was about 13.67%. And now this table shows that. Whereas the probability they're married and do not default is 21%. And so this is a way to show these overall probabilities in each of these categories. And it can let us more easily compare, what groups of people are more likely to default or things like that. But the way that we're looking at this here does not show these conditional probabilities because those are based on the row and column totals. Those are how we find those conditional probabilities. And so in general, if we want to find conditional probabilities, there is a formula that we can use. So here, if I want to find the probability of A given that B occurred, I could look at the probability of the intersection and divide by the probability that B occurred. And you could switch A and B if you're given that A occurs in the bottom here. And so let's look back at that last example and see how we did that there. So maybe let's look at this very last part, the probability that a customer is single if you know they do not default. So using our formula, we'd say we want the probability that they are single, intersect, which is and they do not default, and then we want to divide by the probability of what we're given. So here we're given that they do not default. And so that means I'd want to look at the probability that they're in this category where they're single and do not default, divided by the overall probability that they do not default. So if I do this, this would be about 0.3867 divided by 0.6, and we expect that to be 0.64444. Great. And so rounding made this not exactly what we have in that cell above just because of rounding, but this is doing the same thing. And so the reason for that is in the numerator we'd have a fraction and in the denominator we'd have a fraction, and the denominators of both of those would be the overall total. So let me go in and show you what I mean by this. So if I change these back to just be showing us the values in each of these categories, this conditional probability formula, in the top, I'd be saying that I have 116 divided by my total of 300, and then the probability overall that I do not default is 180 over 300, and those 300s would cancel, and this would end up being 116 over 180, which is exactly the same way that we calculated this in cell B14. That's exactly what we did there. And so this formula is how we can calculate conditional probabilities in general. And let's mention a couple things about this formula. So one thing is, if I have two independent events, that means that one happening shouldn't influence whether or not the other one happens. So if B happens, that shouldn't influence whether or not A happens. Or I guess I should say it shouldn't affect the probability that A happens. So another way of saying that is that two events are independent if the probability of A given B is just the same as the probability of A. B happening doesn't affect the probability of A. In general, we have this formula for conditional probability. What we could do is multiply both sides of that by the probability of B, and that would give us something called the multiplication law. That's saying that the probability of the intersection is equal to the probability of B times this conditional probability. So let's see how this would work with independent events. Well, if I have two independent events, and if I look at this first line for my multiplication law, it has this probability of A given B. If A and B are independent, that's just the probability of A. So if two events are independent, then the probability of their intersection is equal to what we'd get if we multiplied the probabilities of each of them together. So if we look back at that previous example for mortgages, we'd see that the probability that someone was married overall was 0.4766, and the probability that they defaulted given that they're married is about 0.55. And so we could say, if we know these two pieces of information, what's the probability that someone defaults on their mortgage and is married? And so we could use that multiplication law to say the probability of that intersection is the probability they're married multiplied by that conditional probability, and we'd end up getting about 0.26. And so this multiplication law is helpful if we know something about conditional probabilities, but maybe don't know what are called joint probabilities, which are probabilities of intersections. And so this can be helpful if I have information about something conditional and want a probability of an intersection. And so these are helpful things to keep in mind as you're calculating probabilities, to know these rules, to know this multiplication rule. And next, we're going to talk about a law or a theorem in probability that we can use to update probabilities once we continue getting more new information. So here we knew that one thing had happened, and in general, we might kind of get updated information as we go, and we might want to be able to calculate probabilities with that.